Think outside the box. I think in my whole career in industry and in manufacturing, I've heard so many executives, so many leaders, so many thought leaders hear and say this one very short sentence: think outside the box. Well, great quote to start this with this episode with. My name is Jürgen Moers. I am a coach, a strategic advisor, and a consultant, and I focus on manufacturing, on securing the future of manufacturing by educating individuals and by supporting enterprises. Now, today I want to look a little bit about one of the things that I really try to bring, and that's the role of intrapreneurship. And I've built an online course on that. I talk a lot about the benefits of intrapreneurship, but today I want to make it a little bit more practical and talk about this outside of the box thinking. Now, it goes back, I think, about 10 years in my career. And at that time, I was working on a project as a project manager for thermoelectrics. I moved to Germany and I took up the role as a project manager, and the first project that I got was thermoelectrics. Now, for those people that don't understand or don't know what thermoelectrics is, let me explain to you. A thermoelectric material is basically a material. Often it looks like some kind of metal. And if you make it hot on one side and keep it cold on the other side, then the flow of heat that goes through the material at the same time generates a certain electrical current, or it creates an electrical current. Now, this electrical current you could use to power a small device. We can already go back to the Voyager missions of last century that were launched by NASA. They were working with, in this case, radioisotope thermoelectric materials. What it meant was that you had the electric material. On one hand side, you had a radioactive isotope, and on the other hand side, you had the cold of space. And this temperature difference was large enough to generate enough electricity to power the Voyager missions. And if you see Voyager, they're now already at the edge of our own galaxy, our own Milky Way. So they are still active thanks to this radioisotope thermoelectric generator. Now, what was the goal at the time? Like I said, when you have a temperature difference, you can make electricity. Well, the idea was, can we use this to generate a certain amount of electricity out of the exhaust gas of an automobile? Because the temperature at which the exhaust gas goes out the tailpipe is still a couple of 100 degrees. And we have the ambient temperature, which is, let's say, somewhere between 20 and 50 degrees C. Nice idea. Goal was to feed this electricity back to the car, and that way, because a certain amount of the electricity is generated by a generator, and you use basically part of your fuel for it, whether it's gasoline, whether it's diesel. And this way you could bring that amount of consumption down, or even bring it to zero if you want. So that was a great idea, because at that time, we are talking about the period around 2010, 2015, CO2 and carbon neutrality were already high on the agenda, especially in Europe. There were a lot of discussions about it. So basically it was a good idea. But there were some negative elements with it, because you would have to build a heat exchanger, and you would have to put this heat exchanger into the car, into the tailpipe. Now, when you put something in your tailpipe, you also create an additional pressure drop, delta P, meaning that your engine has to work harder to get the gases, the exhaust gases outside into the tailpipe, meaning it could cost you a little bit more gasoline, diesel again. So you have to see where the trade-off is. Now, at the time, this was one of the technologies that was just available for the car manufacturers to reduce their CO2 output. I was a couple of months in that role when I visited a conference on cars and on car technology in general, and one of the aspects was, how can I reduce CO2 for a car, for a gasoline engine, for a diesel engine. What was to me a big surprise at the time, because I'm a chemical engineer, I was not a mechanical engineer, that thermoelectrics was known by most of the car manufacturers. But if I looked at the list of technologies they had to bring down CO2 at that point in time for a car, then it was a list about 25 to 30 potential technologies they could use. And what they did was they looked at what does this technology cost us and what does it bring us in CO2. And if I look at the first top 10, these were typically, let's say, technologies that the car manufacturers know really well, meaning I have to enhance my aerodynamics, I have to make sure that my tires have less resistance on the road, and that way I can, with a very small amount of money, gain a certain increase in fuel efficiency and thus also lower CO2 emissions. Thermoelectrics, you wouldn't even find in the top 20. It would be somewhere down the line. It would bring a relevant saving, but the cost was really high, meaning you could not put it in there so easily. That was the perfect moment to think outside of the box. Now, if I looked at my company at the time, we were active in that, but we were also active in the catalyst industry. And when I looked at a heat exchanger, the structure of that heat exchanger, because you had to make it so efficient to have a very low pressure drop in the tailpipe and still get the maximum of heat outside, started to resemble the existing catalysts that are there to take out other, to put CO into CO2 and nitrous oxide into nitrogen and oxygen, that look more and more on that structure. So we came up with the idea from, if we can bring the thermoelectric generator in to the catalyst or integrate it as one device, 2 in 1, would it be beneficial for the car? So we started testing and working on it. First of all, was it possible? The answer was yes. 2, could we manufacture it? The answer was yes. And 3, what were the benefits? What we saw was that inside the catalyst, the temperatures were typically higher than behind it, meaning we would gain in temperature difference. Another benefit that it created was sometimes, especially in gasoline engines, there are points where your catalyst might overheat, becomes too hot, and this deteriorates the lifespan of the catalyst. And if you can avoid those peaks in heat, then the lifespan of your catalyst becomes longer. Now, if we integrated thermoelectrics, we would shave off those peaks. It would become less warm or you would get less overheating. So there were basically a lot of benefits to do the integration. So we started working on that, started working on a basic first model, and we could show that this technology could actually work. The big disadvantage at the time was we were now in the period 2014-2016, that the trend towards battery and electrical vehicles and plug-in hybrids was the direction that had to be followed, and that was going to be followed by a lot of car manufacturers, which also meant that the market over time for thermoelectric technology, for gasoline technologies, would become zero. And the basic demonstrator pilot project that we had was still rather expensive. We had a huge benefit, but it was still rather expensive in comparison with other technologies. Now, in the meantime, the project is stopped. But the reason why I tell you this is, this was typically out of the box thinking. You have one problem and you're faced, in this case, I needed to integrate thermoelectrics into the tailpipe of a car to generate some electricity. But the benefits were too small. And if you looked at the list, the competitive technologies, it was way big. Now we could have started optimizing inside this small solution, or we could see from, can we make the pie in this case bigger, which was thinking outside of the box, bringing on board an additional business unit, bringing on board and looking at a certain other part of your car. And that was beneficial for the solution that we were after. Now, in the end, the project was not where we wanted to end up because the general trend changed over the course of the project. Why did I tell you this example? Because thinking outside of the box, we sometimes think that thinking outside of the box, and that was also a mistake that I used to make, is that you have to be hugely creative and come up with these Einstein ideas. That's not true. Most of the innovative thinking, most of the breakthrough innovations are often associative ideas. Things that you get from another industry, things that you borrow from another technology. And that is what we have to learn as an intrapreneur, for instance, how we can borrow ideas and thoughts that are not necessarily inside my box, but that I connect to my box or bring into my box. I don't have to come up with the next Einstein idea or whatever. No. A lot of the stuff that we are looking for to innovate, to make a huge step, is often already out there. The question is, do we want to bring it in? And that's one of the things that you really have to learn when you work in a large organization, is associative thinking. And that's what I try to bring to the individuals. Learn to think associatively, because that's one of the ways to become really innovative and creative. But to do that, if you only know one thing in your life, you focused only on one thing in your life, how would you be able to make those associations? You can't. The only way to learn and to get the possibility to think associatively is to learn about a lot of different industries, about a lot of different topics. If you have only one interest in life, it will be very hard for you to think associatively. But if you have many interests, you read a lot, you learn a lot, you think a lot, you talk a lot with people, then it is more easy to generate ideas, borrow ideas from others, from other industries, from other examples. And that's why it's so important that when I talk about securing the future of manufacturing, educating individuals, meaning I can educate you, but you will have to do it on your own. If we want to make our careers in the future a success, especially for the people who will start now or are still early in the career, this is something that you will be able to do. You will have to learn. It's lifelong learning. This is a mantra that already exists for a very long time, but it becomes more and more important because things change really rapidly. So make sure that you learn a lot outside your own comfort zone, outside your own area of expertise. Because the more you do that, the bigger the chance becomes that associative ideas will come to you. And that is how thinking outside the box can become easy. If you have all of those pools of knowledge around you, and you say from this, the problem I have to solve here, this reminds me of something in another industry. Oh yeah, and you get it there. That's one way to go forward. Think outside the box, think associatively.